The story begins when attention slips away, and 3i Atlas is treated like yesterday's headline. In this video, Hubble observations dated December 12th and December 27th are cited as the inconvenient detail because they suggest change, not collapse. A dust cloud measured around 10 micrometers is described as making the nucleus partly opaque, while a double jet and a steady 7-degree wobble hint at control. The same script points to a brightness rhythm near 16.16 hours, later closer to 15.5, like a heartbeat adjusting. That is the uneasy setup. So if it is fading, why would it bother to hide? New Hubble frames become the story's anchor, because they arrive in mid and late December when most people assume 3i Atlas is already on its way out. Hubble, a joint NASA and ESA observatory in low Earth orbit, can catch faint structure when ground telescopes struggle with glare and distance too. According to the narration, the images from December 12th and December 27th show the core wrapped in a dense dust cloud, and spectroscopy points to grains around 10 micrometers wide. In simple terms, that size matters, since particles in this range can scatter light efficiently and make the nucleus only partly see through. The result is a bright coma that softens edges and hides the true outline, yet it is still thin enough that the object can keep moving without obvious drag. That is why the usual comet story starts to wobble. If a fading body is only cooling and shutting down, it should not need a carefully tuned veil that blocks our cleanest view. A mask suggests intent, or at least a mechanism that keeps working when it should be quiet. So what is inside that dusty curtain, and what do the next images reveal when we look closer? The strangest clue is not a flash or a flare, it is the dust itself, because the story claims the cloud around 3i Atlas is built from grains nearly 10 microns wide. To picture that, imagine powder in a sunbeam. If the grains are too tiny, they behave like haze and spread everywhere, and if they are too heavy, they fall out and stop glowing. Around this size, though, they scatter light in a way that can turn a small source into a soft, bright halo, so the edge of the nucleus stops looking like an edge at all. That is why the narration calls it a curtain. A curtain does not need to be solid to block your view. It only needs to scramble the outline, and in astronomy, the outline is everything, since shape is how we decide whether we are looking at a rough rock, a clean fragment, or something stranger. Think of it like frosted glass. You can tell something is there and track movement, but the details vanish, and that uncertainty is where speculation grows. Here is the part that matters for motion. A dense cloud sounds like it should act like a brake, yet the script argues it does not, because the dust is not a wall. It is a veil made of separated particles which can reflect and glow without forcing the object to plow through a thick atmosphere. In space, even a crowded coma can still be mostly empty, so the path stays clean. Now step closer to what this does to our measurements. Telescopes do not see size directly, they see brightness, then they convert that light into an estimate. If the coma is bright, the nucleus can appear larger than it really is, and the glow can hide sharp features that would normally give away a solid body. This is how a small core can wear a big disguise, and the disguise can look natural at first glance. Even the word opaque can be misleading. Partly opaque does not mean the curtain is black. It means the direct signal is weakened because light from the nucleus gets scattered and mixed into the glow, so our cleanest view becomes a blurred average. There is also a second trick. Dust does not only reflect sunlight, it can also soak up energy and emit heat again in infrared, and space observatories can read that signature. If the grains are clustered around one typical size, that pattern becomes easier to spot, which is why the 10 micron number feels so specific in the narration. It is not just dust, It is dust with a fingerprint. So what could create a fingerprint like that? One simple answer is ordinary activity, with jets lifting material from the surface and sorting the grains by how easily they get pushed. A second answer is that the grain size reflects the material itself, as if the surface or vents are producing similar fragments again and again. Either way, it implies consistency, and consistency is the opposite of a dying object that is falling apart at random. That is the uncomfortable takeaway. If you cannot see the heart, you start judging the shadow, and shadows are easy to misread. A mask can make a natural body look artificial, but it can also help an unusual body pass as ordinary. And if the curtain is real, then the next question is not what we see, but what we are missing, especially when the next Hubble frames reveal something that points the wrong way. This is where the story turns from odd to unsettling, because a comet's tail is supposed to be the easiest part to understand. In plain terms, the sun blows. It constantly throws out a stream of charged particles called the solar wind, and that wind acts like a river current in space. Dust and gas from a normal comet get pushed away from the sun, so the tail points outward, almost like a weather vane that cannot argue with the flow. That is why the Hubble frames dated December 12th and December 27th matter so much in the narration. They are described as showing a double jet structure, not one messy spray, and one of those features appears to point into the solar wind instead of away from it. The script calls it an anti-tail, meaning a bright structure aimed sunward, which is the wrong direction for the usual rule of thumb. The moment you hear that, your brain wants a simple fix. Maybe it is a camera trick, maybe it is perspective, maybe the tail is curved and we are seeing it at a strange angle. Those are fair questions, because astronomy is full of optical illusions. Yet the transcript insists this is not a fleeting artifact, since the sun-facing feature stays visible as the object retreats when most comets quiet down. The timing is part of what makes it eerie. By late December, 3I Atlas is moving away from the sun, so it should be getting colder and losing energy. In most textbooks, that is when jets weaken and the coma thins. Instead, the narration describes continued activity and even talks about a stabilized wobble of about 7 degrees around the rotation axis, as if the jet is anchored near a pole and kept in place. A reader does not need advanced physics to feel the tension here. If the wind is the current, then a sunward jet looks like a swimmer pushing upstream. It might still be natural, but it would need an explanation that fits the conditions, not just a shrug. There are natural cases that can confuse people, like dust trails that line up with an orbit, or sunward features caused by the way particles spread. But those cases usually change fast, and they do not look like a focused nozzle. The transcript frames this as a structured jet, and structure is what raises eyebrows. Solar wind is not gentle either. Near Earth, it often flows at hundreds of kilometers per second, commonly around 400 to 800, and it carries magnetic fields that can twist comet plasma into long blue streamers. When something stays pointed sunward under that kind of pressure, it feels like more than leftover debris drifting. The narration also stresses that there are two jets, which matters because two separate vents suggest geometry, almost like the object has an upside and a downside. So we end up with a simple, uncomfortable comparison. A typical comet follows the rules because heat drives the release and the solar wind shapes what escapes. This object in the story we are following seems to keep a sun-facing stream active even as it cools, which hints at control rather than pure reaction. If the dust curtain in the last chapter hides the body, then this jet is the first clear behavior we can track, and it points exactly where it should not. What kind of engine or process keeps firing into the wind when the sun is no longer feeding it for this long? The sun-facing jet becomes far more disturbing when it is treated not as decoration, but as behavior right now. In the usual comet picture, Sunlight warms ice, gas escapes, and dust follows, so the bright stream is basically a messy bruise from heating. That explanation feels comfortable because it says the comet is not choosing anything, it is just reacting. Yet the transcript invites a different reading, and it does so by focusing on direction, stability, and timing. First comes the direction. One jet is described as aimed toward the sun, straight into the flow that should push everything back. If that feature were only leftover dust, it should smear, curve, or vanish as conditions change. Instead, the narration frames it as something that holds its line, like a hose that keeps pressure even when the room gets cold. Then comes the stability. The script mentions a steady wobble of about 7 degrees around the rotational axis, with the jet anchored near a pole. That detail matters because random venting makes objects tumble, while a pole-aligned source suggests a fixed orientation. It is like watching a lighthouse that keeps sweeping the same arc, not a campfire that flickers wherever the wind feels like going. Now bring in the timing. Late December is not the moment when a normal comet should look energetic because it is moving away from the sun and losing heat. Many comets fade fast after perihelion, and the coma thins as their easy fuel is spent. The transcript argues that 3I Atlas does the opposite. It continues to present a focused feature that appears organized, which makes the simple heat story feel incomplete. This is where the shield idea enters. Avi Loeb is referenced as suggesting the sun-facing stream might be a defensive exhaust, an active flow used to deflect radiation and protect the core. Whether that is correct is a separate question, but as a narrative move, it forces a cleaner test. If the jet is serving a purpose, then it should persist when that purpose remains, even if sunlight becomes weaker, because the driver is not passive warming, it is an internal process. There are natural ways to get surprising jets, and any honest look has to admit that. Pressure pockets can vent, uneven terrain can focus a plume, and dust can line up in odd geometry. Still, those cases often look chaotic over time, because the source changes as material erodes. The transcript emphasizes precision, which is exactly the trait that makes people uneasy. So the real question shifts from what the jet looks like to what it costs. Pushing material sunward takes energy, and keeping a stable orientation implies some balance. If the object is colder, where does that energy come from? If the pole stays consistent, what keeps it from wandering? The narration never claims a confirmed power source, yet it hints at possibilities that feel unsettling. It could be stored chemical energy, a slow release of trapped gases, or a reaction triggered by stress inside the body. All of those are natural options, but they still mean the object carries its own fuel reserve. The shield hypothesis does not have to be true to be useful. It functions like a spotlight, turning a weird shape into a motive. It asks the viewer to stop treating 3I Atlas as scenery and start treating it as an actor. If that actor is spending energy on protection, then the next chapter has to follow the rhythm behind it, because any system that shields itself also has a heartbeat. The most unsettling detail is the rhythm, because long before the talk of shields, observers in the script claimed 3I Atlas was already pulsing like a signal in the dark. Earlier in the year, astronomers watching its brightness reported a periodic rise and fall that kept returning on schedule. The transcript calls it a 16.16-hour cycle, which sounds like a small statistic until you realize what it implies. Objects in space can flicker for many reasons, yet true periodicity usually points to rotation, meaning the body is turning and showing different faces to the sun and to our telescopes. In real observing, that repeat comes from the same target measured across many nights, then plotted as a light curve. When peaks line up again and again, the number stops being a guess and becomes a fingerprint. What makes this pulse feel different is how calm it appears. A crumbling comet can brighten in bursts as it sheds pieces, but those flashes tend to be messy and irregular, like a candle in the wind. Here, the pattern is described as steady, a repeated beat that hints the object has a fixed orientation and that its active region keeps coming back into view at the same interval. A simple explanation is shape. If the nucleus is elongated or has a bright patch, rotation can create a repeating light curve, and many asteroids and comets have known spin periods measured in hours. Yet the story insists this one looks less like random glare and more like a cadence, almost as if the object is keeping time while it travels. Then the script adds a twist. By late December, as 3I Atlas retreats and cools, the pulse is said to shift from 16.16 hours to around 15.5 hours. That change matters because a spinning body does not usually change its rate without a cause. In real physics, there are natural ways to speed up, such as uneven outgassing that acts like tiny thrusters or mass loss that alters how weight is distributed. Skaters spin faster when they pull their arms in, and a comet can mimic that effect when material leaves unevenly from one side. But the narration frames the shift as something else. Instead of a dying object losing control, it sounds like a system adjusting its settings, and that is where the word recalibration enters. Recalibration is not proof of intelligence, yet it carries a different emotional weight than erosion, because it suggests the object is still coherent enough to change without breaking. It also connects back to the earlier chapters. A dust curtain can hide shape, and a sun-facing jet can look like a controlled stream, but the heartbeat is harder to dismiss as a simple illusion. A rhythm can be tracked across nights with basic tools, and even if the exact numbers are debated, the existence of a steady beat makes people listen closer. At this point, the viewer is forced into two competing pictures. In the comfortable picture, the pulse is just rotation plus ordinary activity, and the slight speed up is a side effect of natural venting. In the uncomfortable picture, the object is managing its behavior as it exits, and the beat is a clue that something inside is still running. The chapter ends with a quiet problem. If 3I Atlas is truly fading, the rhythm should drift into noise, not tighten into a new tempo. So why does a supposed corpse keep time, and what does that timing reveal when we connect it to the jet that points the wrong way? The chapter tightens because the numbers stop being poetic and start sounding like a performance report. In the transcript, 3I Atlas is said to be throwing material into space at more than 1 kilometer per second, which is about double the speed often linked to simple solar heating in typical comet discussions. That matters because speed is not just movement, it is energy, and energy has to come from somewhere. To make that speed feel real, picture a passenger jet at cruise. It moves near 250 meters per second, and most people already call that fast. The transcript's dust number is roughly 4 times that, and it applies to tiny grains leaving a cold body in deep space. Even if the particles are small, the momentum adds up, so sustained outflow at that level suggests a strong, steady driver instead of a brief sputter from a cracked surface. As the object moves away from the sun, the usual fuel source weakens. Sunlight drops fast with distance, so a cold body should struggle to keep blasting dust as if it were still near the heat. The script mentions the common expectation of around 500 meters per second for natural warming-driven outflow, then contrasts it with the higher figure and treats the gap as the key clue. This is where the dust curtain becomes more than a mask. A cloud can hide shape, yet the ejection speed hints at what the cloud might be doing. If grains are leaving at such a rate, then the source is not a gentle leak. It looks like a push, and the narration frames it as either a mechanical force or a deliberate release sequence. Then the story pulls the camera back and follows the route. It says that in March 2026, 3I Atlas will reach Jupiter's Hill radius, the region where Jupiter's gravity begins to dominate over the Sun's pull, and it will use that gravity as a slingshot. In plain language, that is the cosmic version of catching a fast-moving train, letting it drag you forward, then stepping off with extra speed. Gravity assists are real, and they are used by human spacecraft because they save fuel and extend missions. So when a strange visitor lines up with a big planet at the right moment, the path can look smart even if no one planned it. The narration admits that, yet it leans on how efficient the sequence feels, as if the object is pressing the biggest keys in the system. It goes further by describing the route like a survey, not a random pass. Jupiter is not just a planet, it is a gateway to moons that many scientists consider promising, including Europa and the icy worlds farther out. If a traveler wanted to check for life or drop tiny sensors, the story argues this is the kind of corridor it would choose. At this point, the viewer has to hold two truths at once. Orbital mechanics can produce neat paths without intention, and nature can surprise us with jets we did not predict. Yet when speed, dust behavior, and trajectory all point toward efficiency, the coincidence starts to feel heavy. So the chapter ends on a choice. Either 3i Atlas is an extreme natural object that happens to behave in the most dramatic ways at the most interesting moments, or it is an engineered visitor using physics like a tool while hiding behind its own glow. If it is leaving on purpose, what exactly does it want from one last close encounter with Jupiter's domain? This story ends where it began, with silence that feels engineered rather than accidental. In the script, Hubble is said to catch 3i Atlas on December 12th and December 27th, and what looks back is not a simple fading smudge. A core sits behind a 10-micron dust curtain, so the brightest shell is not the same as the body itself. Then comes the detail that refuses to fit. A jet appears to face the sun, holding its line against the solar wind, while the object cools and drifts outward. Add a steady wobble near 7 degrees, and the scene starts to feel less like weather and more like design. Even the light behaves like a clock. The narration points to a 16.16-hour pulse that later shifts near 15.5, a beat that changes without breaking. And the route stays sharp, aiming for Jupiter's Hill region in March 2026, as if gravity is the last tool it plans to use. Silence can mean nothing happened, but it can also mean the plan worked. A mask does not need applause, it needs time. Maybe it is extreme nature, and we are projecting meaning onto patterns. Or maybe the patterns are the message, and the message is that we were never meant to see the core. So tell me this in the comments, and subscribe if you want more deep sky updates. If something crossed our system, hid behind dust, and left without speaking, how would we prove it ever came at all?